All right, this is section 1.2, which is called functions. So the following things you're going to learn in this section: how to determine whether or not a relation is a function, how to use function notation and evaluate functions, how to find the domains of functions, how to use them to solve and model real-life problems, and then how to evaluate difference quotients. So as far as the definition for functions, a function, and usually we use the letter f, so let me go and put that. A function f is where each element in its domain corresponds to exactly one element in the range. So there's a couple ways that we can visualize this and determine this. We can use a graph, we can use a table, we can actually use equations. But the important thing that you guys must know is each input has exactly one output. So highlight this so you guys know this. So testing for functions. So example. So determine whether the relation is a function. Okay, so for part A, let's go ahead and do a table. So we give you guys a table where the inputs are 2, 2, 3, 4, and 5. And the outputs are 11, 10, 8, 5, and 1. Okay, so if you guys remember what I just said, each input can have exactly one output. So if this is supposed to be a function, 2 gives us 11. If we plug 2 into the function, it gives us 11. But if we plug 2 in, it also gives us 10. So notice that 2 gives us 2 different outputs. 2 gives us 11 and 2 gives us 10. And since they're not the same number, that means that this can't be a function. No. And you don't have to explain right now, but I'm going to anyway because that way you guys know. Because the input 2 has 2 different outputs. Okay. For B, draw a quick graph. So I'm going to plot a couple points. Okay, so if we look at the different inputs we have are -2, looks like, and 1 gives us output. But notice that none of these inputs repeat. So yes, this is a function. This is a function. Okay, so how to test for these algebraically. So determine whether each equation represents y as a function of x. So for part A, we have x squared plus y is equal to 1. So we want to represent y as a function of x. That means just to solve for y. So if we look at this first one, to get y by itself, we're just going to subtract x squared from both sides. So you get y is equal to negative x squared plus 1. Okay? Well, this is a parabola. Y equals something x squared plus a number. This is a parabola. So if you think about a parabola, okay, I'm just going to use transformation rules. This is going to take the parabola and reflect it. So it's going to be upside down. And then the plus 1 is going to move it up 1. It's going to look something like this. Okay? None of the inputs are going to repeat for a parabola. So this is a function. So yes. For B, we have negative x plus y squared is equal to 1. Well, to solve for y, I'm going to move the x first. So I'm going to have y squared is equal to positive x plus 1. And then to get rid of the square, I'm going to square root both sides. So y is equal to, remember, whenever we solving an equation, we have to square root both sides. That's going to give us a plus or minus. Now, because this plus or minus, that means that if we plug in an input, we're going to have two different outputs because one of them is going to be positive, one of them is going to be negative. Okay? Which means that this is not a function of x because if I plug in, let's say like 0, if x is 0, then y equals the positive square root of 0 plus 1, which is just square root of 1, which is 1. But if we plug into the other one, and we use the negative square root of 0 plus 1 is going to be negative square root of 1, which is negative 1. So see here, because of the plus or minus, what it does is it gives us a 1 and also gives us a negative 1. So this one is not a function. Okay, definition, function notation. Your book kind of gives a funky definition, so I'm going to try to give you guys a more simple one. So when an equation is used to define a function, we use function notation. F is the most common name we use, but as you guys have seen from other classes, we can also use like g of x, h of x. Those are common. Sometimes you see like k of x, but those are all just function names. Okay, so in general, we have the input, x, and then the output, we plug x into the function, and we get f of x. So taking the one of the answers from the last problem, we can rewrite it as f of x is equal to 1 minus x squared. Okay, so if I wanted to find like f of 1, that means to change the x to 1 and evaluate. Okay, so this is what you guys need to know. F of x is the output, and x is the input. So, example. Let g of x equal negative x squared plus 4x plus 1. Find each value of the function. Okay, so for part A, we're going to find g of 2. So what that means is, remember, we're going to take each input and we're going to replace it with 2. So wherever you see an x, we're going to replace it with 2. So g of 2 is going to equal negative parentheses 2 squared plus 4 times 2 plus 1, which is going to be equal to negative 4 plus 8 plus 1. Negative 4 plus 8 is 4, plus 1 is 5. For part B, g of t. So these ones sometimes stump students, but all it means is, remember, you're taking wherever you see an x and you're changing it to t. So this is going to equal negative parentheses t squared plus 4 times t plus 1. Okay, if you simplify, t squared is just t squared, but then we're making it negative. So negative t squared plus 4t plus 1. Okay. Now, it's not asking us to factor or anything like that. We're just plugging it in. So this is our answer. In the next chapter, if it asks us to also factor, then we could. But that's not until chapter 2. C, g of x plus 2. Okay, so I'm going to copy this so we have it and bring it down. So this was our function. So wherever you see an x, remember you're going to change it to now x plus 2. So this is going to go wherever you see an x now. So it's going to be negative parentheses x plus 2 squared plus 4 times x plus 2 plus 1. Well, x plus 2 squared is the same thing as x plus 2 times x plus 2. Distributing the 4, you'll get 4x plus 8 plus 1. Okay, I'm going to multiply this out. So x times x is x squared. X times 2 is 2x. Then 2 times x is 2x. 2 times 2 is 4. Okay. Plus, simplifying the outside, you're going to get 4x plus 9. Okay. Simplify, combine like terms. Negative parentheses x squared plus 4x plus 4 plus 4x plus 9. Okay, I'm going to distribute this negative now to everything. You're going to get negative x squared minus 4x minus 4 plus 4x plus 9. Okay, and then these are going to cancel. You're going to get negative x squared plus 5. Okay, piecewise function. So you guys may remember this from Math 2, maybe not. But a piecewise function is a function that is defined by 2 or more functions at a specific domain. So to evaluate a piecewise function, so we are going to evaluate the function when x equals -1 and x equals 0. So f of x is going to equal, so piecewise usually has this brace. It's going to be x squared plus 1 when x is less than or equal to 0, and x minus 1 when x is greater than 0. And I already messed this up. So if you're watching this, sorry. X is less than 0 is the top one, greater than or equal to 0 is the bottom one. Okay, so if I want to know what the function is when x equals -1, so in other words, that's asking us to find f of -1. So because it's piecewise, what you have to do is you have to pay attention to the domain. So where is -1 in terms of the function? So this function, we use this function when x is less than 0. So ask yourself, is -1 less than 0? And it is. So that means that I'm going to plug -1 only into this part. Okay, we only use this function whenever we're using values that are greater than or equal to 0. So if we're plugging in -1, we're going to use the top one. So this is going to be equal to -1 squared plus 1, which is the same thing as 1 plus 1, which is 2. When we're plugging in 0, that means that looking at the domain, if x is greater than or equal to 0, we use the bottom one. So we're going to use this one. So x minus 1, so 0 minus 1 is -1. Okay, domain. Again, your book gives you a pretty complex definition, so I'm going to try to simplify it for you. The domain of a function is the set of all possible inputs used to define the function. So in other words, the x's we are allowed to plug in. So just a couple quick ones. If I give you guys f of x is equal to 1 over x minus 3. Okay, so this is something that you guys learned in math 3 is a rational function. Remember, we're never allowed to divide by 0. So if you look, the only value that makes the bottom 0 is 3, because 3 minus 3 is 0. So the domain would be all real numbers except x can't be 3. Okay, but in precalculus, we're going to write it in interval notation. So if x can't be 3, but we can use any other number besides that, then we write it in interval notation. As -infinity to 3, and then union 3 to infinity. Okay, so basically this is saying every number except 3, so we have to write it this way because this ensures that we skip 3. If we write a bracket here, that means we can use 3. Parentheses means you can't use it, and we also use parentheses for infinities. Something more simple, like f of x is equal to the square root of x. The only numbers that we can't use are negatives, but we can use 0 or bigger. So the domain would be x is greater than or equal to 0. So in interval notation, that would be bracket 0 to infinity, because we can use 0 or anything bigger. All right, so example. Find the domain of each function. So for part A, f is going to look like this. Brace, then the points -3, 0, -1, 4, 0, 2, 2, 2, and 4, -1. Now, we're not graphing this. This is just a list of points. So we don't even know if these are connected or not. So we can't really write it like this. So whenever it's just a list of points, the domain, capital D, is just going to be a list of the x values that were used. So if we look at the x's, we have -3, -1, 0, 2, and 4. So the domain we're going to write like this. It's going to be curly brace, -3, comma, -1, comma, 0, comma, 2, comma, 4. And that's all you have to do for that. Okay, but let's do an actual function. So g of x is equal to -3x squared plus 4x plus 5. Okay, so for something like this, okay, this is a polynomial function. Specifically, this is a quadratic function. So if you guys remember from Math 2 and Math 3, the domain of any quadratic function, any parabola, is all real numbers. So the domain is all real numbers. So to write that in interval notation, the domain is going to be equal to -infinity to infinity. For part C, h of x is equal to 1 over x plus 5. Okay, so this is a rational function. So remember, we can't have the denominator be 0. So the only x value that makes the bottom 0 is -5. So x cannot be -5. But we could pick any other number besides -5. So the domain is going to be -infinity to -5 union -5 to infinity. For part D, k of x is going to be equal to the square root of 4 minus 3x. Okay? The only type of numbers we're not allowed to take the square root of are negatives. So basically, for something like this, you take the inside, and we want the inside to be greater than or equal to 0, because then we could take the square root of it. So subtracting 4 from both sides. Oops. And then dividing both sides by -3. Whenever you divide by a negative, the inequality sign changes. So x can be anything less than or equal to 4/3. So this is the biggest it could be, but we could pick anything less than or equal to it. So that means that the domain is going to be -infinity all the way to positive 4/3, the bracket. Okay, so I should have covered this up, but I'll show you guys where this came from. But for the next problem, it says to use a graphing utility, so graphing calculator, to find the domain and range of f of x is equal to the square root of 9 minus x squared. Okay, so where did this come from? This came from the TI calculator. So one of the newer ones that you guys hopefully will be getting soon. So if I go to my calculator, on the top left-hand corner where it says y equals, okay, square root, so second x squared gives you a square root. The function they want is 9 minus x squared, and hit graph. Okay, I'm going to zoom in because it's a little small. So if I click zoom in, I can do it again so it gets even closer. Okay, so if you guys see that, it looks like it's only above the x-axis, and it looks like it's getting really close to 3. So if I hit trace, -3, I get negative 3, 0. If I trace again and positive 3, I get 3, 0. So it looks like the domain, the x's are only between negative 3 and 3. So if I go back to my notes, the domain, this only goes between negative 3 all the way to positive 3. So the domain is going to be, bracket negative 3 to 3. And then the range is the y's. The lowest y value is 0. Okay, and the highest y value is 3. So the range is going to be 0, 3. Okay, example 7. Word problem. A baseball is hit at a point 3 feet above the ground at a velocity of 100 feet per second. At an angle of 45 degrees. The path of the baseball is given by the function f of x is equal to negative 0.0032 x squared plus x plus 3, where f of x is the height and x is the distance from home plate. Okay, question asks, will the baseball clear a 10-foot fence that is, I'm going to write down here, that is 300 feet from home plate? Okay, so basically what we need to figure out is if f of x is the height, okay, and x is the distance, if I hit a ball that is 300 feet away from home base, that means that with this function that they give us, I just need to plug in 300 in for x and see what happens. So algebraically, f of 300 is going to be equal to negative 0.0032 times 300 squared plus 300 plus 3. And if you simplify that, you get exactly 15. Okay, so remember, the F part represents the height. So we want the ball to clear a 10-foot fence. So in other words, as long as this number is greater than 10, the ball is going to go over the fence, and it does. That means the kid hit a home run. Okay, so because this is greater than 10, that means that yes, the ball will clear a 10-foot fence. Okay, now you can solve this using your calculator too. So the TI looks a lot better than the calculator I'm going to show you guys. But if you plug this into your calculator, so let me show you guys. we hit y equals negative 0.0032 x squared plus x plus 3 and hit graph. I'm going to zoom out, zoom way out. Okay. Let me do. I'm gonna change the window. So I want x to be 0 all the way to, let's do 350, and then graph it. And the y's, let's do -5. Oops, -5 to 20. Still can't see it. I don't know what the max is. Let's do the max is 50. Okay, that's a little better. So it kind of looks parabola-ish. But anyways, if you hit trace, and then we want to know what happens when it's 300, and hit enter, it gives us 15. So when x is 300, y is 15, so that gives us the answer to the question as well. So here it's a lot easier to see. And I'll show you guys how to do this in class, but if you do the trace button and then just type in 300, hit enter, it tells you y is 15. So this is where it's actually plotted on the graph. So 300, 15, the height is 300 when the ball is 300 feet away from home plate. Okay, last example. Difference quotient. So this is really important for calculus as well, and it's gonna come up when you guys learn about, it's called derivatives. So difference quotient is a ratio, which is f of x plus h minus f of x all over h, is called the difference quotient. And just put a star next to this. Important idea in calculus. So whenever we use a difference quotient, the idea is to simplify a function as much as possible. So for our problem, for the function f of x is equal to x squared minus 4x plus 7, find f of x plus h minus f of x all over h. Okay, so to make this simple before we do it, the goal is to simplify as much as possible and things should cancel out. And if they don't, that means we did something wrong. Okay, so again, this is just function notation. So f of x plus h, this first part means that wherever you see an x, you're going to substitute it with x plus h. So at the beginning, we're going to replace every x with x plus h. So this is going to equal x plus h squared. I'm going to actually put a bracket around this. And then minus 4x, but remember we're changing the x to x plus h. So minus 4 times x plus h plus 7. Okay, minus, okay, so that part's done because we plugged the x plus h into every piece where there's an x. Now we're subtracting f of x, but f of x is just the function, so this doesn't change. So this part, we're just going to basically just copy and paste this right there. So minus, parentheses, x squared minus 4x plus 7. Okay, simplify on the inside. X plus h squared is the same thing as x plus h times x plus h. Okay, so visually it might be easier just to use a box. So this would be x squared. X times h is just xh. This is another xh. This is h squared. So I have an xh and an xh. So if I add those together, I have 2xh. So x squared plus 2xh plus h squared. Distribute the negative 4. Minus 4x minus 4h plus 7 minus, I'm going to distribute the negative to everything on the inside. So minus x squared plus 4x minus 7. I already forgot something. This should all be over h because I forgot about that. So this should be over h, and then this part should be over h. So this equals, okay. Now, do we have any like terms? I don't see any like terms. Okay, so now because there's no like terms in here, I can remove the braces. So now we can combine like terms with anything here. So notice I have a 4x and a negative 4x. So those are going to cancel out. I have a 7 and a negative 7. I have an x squared and a negative x squared. So what I want you guys to notice is these all canceled out. Then everything else that's left over, notice that they all have in common an h. So I'm left with 2xh plus h squared minus 4h all over h. So to simplify this, I could factor out an h on top, and I'm left with 2x plus h minus 4 all over h. And then I could divide out the h and give me 2x plus h minus 4. And I am done.